Let me introduce myself a little more. Currently, I'm a solution architect in Exness, and previously I spent a lot of years in different big IT companies as architect, product manager, evangelist, and I developed big distributed systems. I participated in development of database and queue systems, and during this journey, I found that identifiers is a very common part and very important part. There is a lot of different approaches when we're talking about how to identify something, how to generate some identifier. And I started some research and found it's an interesting topic to share it with you. So I want to start from, let's say, classic approach. It's called auto-increment. When you use classic relational database, you are familiar with auto-increment. It's kind of traditional. It has existed for ages, and it's everything okay with use of auto-increment. It has a lot of pros. You may use it. It's easy to understand, easy to implement. Everything is good, except when you face the scaling your system up. When one database is not enough, when centralized coordination is a problem, you cannot use auto-increment for systems like Twitter or Netflix. You need to use something else. If we are talking about distributed databases, then auto-increment is not a way to use. The question I faced several times, our users of Tarantul database came to us and asked, how can I use auto-increment inside Tarantul? And the regular answer was from either us or our community, you can't. You cannot use auto-increment in a distributed database. Just use UUID or ULIT or something else. So I need to introduce you different approaches, and for the first one would be UUID. It was created 20 years ago. It's universally unique identifier. It has the following representation. You can take a look at it. And one thing I want to mention, it's universally unique. It's unique across the universe. It's not a universal identifier for everything. It's not general purpose identifier. It's just universally unique. And for achieving this universally uniqueness, there are a lot of different approaches. So first, RFC for UUID consists of several versions, and they implement different approaches to uniqueness. So let me introduce you the first one. The first one is UUID version 1. It's so-called time and node based. During my whole presentation, I will use the following color coding for different parts of bits representing something inside the identifier. There would be different parts. It would be random, timestamp, sequence, node ID. So this color coding will be used across different identifiers. So UUID version 1. It consists of timestamp, the sequence, and node ID. Those days, as node ID was chosen MAC address, a little bit amount of sequence for numbers generated within that node, and with it then given timestamp. Timestamp represented in Georgian calendar and is measured by hundreds of nanoseconds. So how UUID version 1 achieves uniqueness? It generates, it allows us to generate 16,000 unique identifiers per node per 100 nanoseconds. In another 100 nanoseconds, we can generate next identifiers and next one, and that result in a very huge amount of unique identifiers per node per second, and that guarantees us universally uniqueness. If we have a lot of different nodes and we uniquely identify them, and even within any 100 of nanoseconds, we generate a lot of different identifiers. So that's not the only approach. It's the common and the most basic approach, but there are also maybe another approach. It's called natural identifiers. As Vasily told at the beginning, all of you have names. I believe all of you have names. But sometimes names may expect a collision, so some people may be named in the same way, so we need to add the place of birth, the date of birth, and something that's rather unique. I say the place of birth, the date and time of birth, and the name, but that's not a good unique identifier. It's variable in its length, it has different representations. So what is the natural identifier? It's something that's stable and predictable by some input. We can use domain names or people names or something else, and for the same input, they yield in the same output. There are two versions of UUIDs that allows us to create natural identifiers. It's UUID version 3 based on MD5 and UUID version 5 based on SHA-1. They are the same in their nature, they only use different hashing function. And in between of them, UUID version 4, I think the most popular one, it's purely random. UUID have 122 bits of content, and if we use such amount of random, we will face no collision in a very long time span. So we can use random to generate something unique. And this is the most popular UUID to the date. Because you need no coordination, you need nothing to do to get a precision timestamp. You don't need to identify your node. For example, you can generate them in browser because there you have no MAC address or something else. So it's the most popular UUID. If you count all the UUIDs, that would be the first place. For the random, you can use different sources, and I want to highlight it's not a good idea to generate UUIDs from true hardware random because it's exhaustible and you will be limited by the output of that random, and your TLS or SSH will suffer. It's good enough to use dev-urandom, pseudorandom from kernel, it's good, but random brings us a problem when we turn that identifiers and put them inside a classic relational database. Most of classic relational database utilize B-trees. B-tree is an index, it's a structure, and it's designed to be updated in the most recent, let's say, leaf of the data. They was designed to insert things like auto-increments. You create new entity, it's inserted in the end of the tree. So tree updated only by one branch. And when you start inserting UUIDs, version 4, in such database, they expect a dramatical drop down in performance. Because you update the whole index all the time, all the pages, it yields in write amplification, performance degradation. So, in general, we face a lot of problems when we use UUIDs as an identifier in that place there were used auto-increment previously. And one more thing to highlight, UUIDs are not very friendly in their representation for transmission. We often transmit our identifiers in a string format. It may be JSON, it may be something else like XML, and their string representation is not very good. It's very big, it's not so compact, so it fits okay into the database, but string representation, it's not so good. So let's consider some alternatives. Which alternatives we have and what can be a better successor for auto-increment or UUID in the common, our modern distributed world? This question was asked by different people in different companies that were growing, and there are a lot of approaches to fixing UUIDs or to implementing something alternative to UUID or auto-increment. And to address this question on how we can create a good, unique identifier, I want to highlight and maybe ask a question to you. What can be a natural monotonic sequence? Yes, you are right. Time is a very good natural monotonic sequence. It only grows up. It's truly monotonic. And we can count it with precision of nanoseconds, which gives us billions of different entities within a second. And we can represent nanoseconds in 64 bits integer. Seems quite good. Rare system can produce more events and more entities at such speed, but there is a problem with time. We cannot know exact time on the different hardware because okay, the time exists, it's truly monotonic, but we cannot measure it with that precision we really need. So in fact, our different servers and our distributed system will have different times with which have slight offset from real time. So that may be a problem or maybe not. To fix that, we cannot fix the problem with time. But we can fix the approach. We can think of, let's consider how we treat, for example, news. There is today news, there is yesterday news, a week ago news, and tomorrow news. We don't care really about the exact order of that news within a day. We just care about their generic order across their lifetime. So if we really don't care about slight reordering, we may consider that this sequence is almost monotonic, or roughly sorted, or k-sorted within a k distance. This approach can be applied to generation of timestamps for identifiers. And if you take a look from the far, as you see now, you can face that despite the fact it's kind of random, in general it's monotonic. So we may utilize k-sorted approach for timestamps to create identifiers, and now we will try to use those 64 bits and to build some identifier that will be truly unique and still fits into this amount. That was done 15 years ago by Twitter. If you read Twitter, if you've seen their URLs, you may face that every tweet has an identifier, and that identifier created exactly by this scheme. Twitter decided they need a lot of different identifiers for their short posts. They want they to be quite compact because they planned there would be a lot of them. So they decided they fit to 64 bits. They cannot use auto-increment because auto-increment is limited by generation of single hardware. So they wanted to scale ID generation to different servers. They created different ID servers that any application may contact and ask for new identifier. And to maintain that idea, they created a structure that lies behind that implementation. It builds on top of several bit groups, just like in UUID version 1, but with some adjustments. They reduced the amount of node ID to only 10 bits. 10 bits is 1,000 nodes, quite enough for having such amount of ID generation servers. They divided them by data center and node ID within that data center, but we don't care. We can thread them as a single space of 1,000 nodes. They have timestamp, and for timestamp they use at first milliseconds, but it's not classic Unix milliseconds, but Unix millisecond adjusted by roughly 40 years. Sorry. And why they can do that? Because they don't need to create identifier in the past. Identifiers created only in the future. So there is no need to waste a lot of bits for timestamps in the past. So at the moment of their creation, they took a timestamp that was in recent past, and they gain extra 40 years to generate their identifiers. For the sequence, they have quite big amount of generation per identifier, per millisecond, per node. So the system allows them to generate a lot of different identifiers. And they have left one more bit, and they decided to use it for nothing. I call this as a waste. in identifiers, they serve no purpose. They just say our identifiers would be sign safe. So we would not care is integer is signed or not. This scheme of ID generation was copied by different companies. One of them is Discord. They decided that we should not care about those sign bit and use one more bit for timestamp. Quite simple update. ID looks almost the same. The same was done for Instagram. They implemented their own sharding. They need to uniquely identify items within different shards. They created some more updates. They adjusted the bit layout. They needed more nodes, so they switched several bits from sequence, reducing the amount of identifiers from every node to the amount of nodes. The same was done by Sony. They needed to create a lot of identifiers from big amount of nodes, so they dramatically increase node space by reducing timestamp and by reducing the sequence. So by their requirements, they create their own approach with the same layout and still fitting in 64 bits. One more interesting thing, they swapped in the place the sequence and node ID, and that results in more smooth monotonicity because they used timestamp not in milliseconds, but in tens of milliseconds. So within tens of milliseconds, they create a sequence that yields more monotonicity for identifiers. And almost the same layout is used by a database Hazelcast. They already had an identifier for every node, so they just put their node ID inside identifier and generate the ID. We see that when we experience problems with some capacity for nodes or for timestamp, we try to steal bits from other parts, reducing their quality. So what if 64 bits is not enough? We can go beyond that, and if we were OK with UUIDs, then we can double the space, and then we have a space for everything. That's the flake by boundary. It uses 128 bits for the whole ID. They used another alphabet, rather compact and dense alphabet. And they use, since we have enough space, classic milliseconds with Unix epoch, a lot of space for MAC address or other kind of node ID, and quite big sequence for generating 16 millions of identifier per millisecond. It has almost the same layout as Twitter Snowflake, but stretched a lot. Or it may look similar to UUID version 1 in their nature, but another in layout. We can compare base 64 to UUID, and we may see that it's way more compact. It's twice compact in its string representation and the same in bits representation. And one thing to note, if you want to encode some amount of bits into representation with another alphabet, there is a formula, and if you put those numbers into the formula, you found that 128 bits should be encoded into 22 characters. How that could be? We see that flake ID is only 18 characters, but we need 22. The trick is about time. The time part comes in the first, and it may vary from 0 to 11 characters. For the 0 timestamp, it would be 0 characters. For the full timestamp, it would be 11 characters. And for current timestamp, it only 7 characters. And if we take a look deeply into the timestamp and its exact values, we may find that for our lifetime span, we will have this identifier of the length of 18 characters. And we see that its growth by only one character in 20,000 years. So that's quite big. So we may consider this identifier as, in fact, 44 bits for timestamp and 108 bits in total. But it can be easily fit into 128 structure like UUID. Along with that, there are several another implementation. There is Elastic Flake from Elasticsearch. Almost the same layout, a little bit adjustments for sequence, for node ID, for timestamp, and another alphabet. MongoDB as a database also generates identifier, and here is the first change that we may face. We get rid of node ID. MongoID decided not to search for something unique that may be used as a node ID and instead use randomness. Randomness is a thing that may result in collision. We cannot guarantee that two random numbers will not collide. So when we face something random, we always must think of probability. But for such amount of bits, and such consideration, we may face that we have quite a low probability collision within 1 millisecond. And we may face the regeneration of random only when we exhaust sequence generation. So we took a timestamp, and within that timestamp, we should generate 16 millions of identifiers, and then we face exhaust of sequence, and then we need to generate a random number, and we have a very low collision probability. So that's a good identifier. I'm not sure that anyone may see collision from MongoID object identifier. And they use not very good alphabet. As for my side, hex alphabet quite long. It's 24 characters. And for those who want to use more dense alphabet, there is a XID. It's like MongoID, the same bit layout, the same approach, but encoded in base 32, resulting in 20 characters. And if we are talking about if random is so good, why not to throw that sequence and to use only random? And KSOID is about, let's use huge amount of random, that amount like used in UUID version 4, and make them sortable. And to make them sortable and monotonic, just put Unix timestamp in front of it. KSOID is very long. Its string representation is 27 characters. It has extremely low probability for collision because it itself contains a UUID inside. I really like the article that was written by the guys that created KSOID. To be true, this article was an inspiration for me to start research and to create this presentation. So I want to do a favor for them and to share this article. If you are interested in, you may also take a look at it. So let's go back to KSOID. They state that they have a very low probability for collision within 1 second for generating 1 million identifier. Is it good or bad? How this probability is okay or not okay, and which probability is good for different systems? Brief research brings us to the following requirements for numbers. Even for critical systems, systems like financial system or security critical system, 10 to power minus 12 is quite good for collision resistance. So 10 to power minus 27 is too much. We don't need such an amount of probability resistance. So the next identifier is one of the most balanced from my side. It's ULID, Universally Unique Lexicographically Sortable Identifier. This identifier was an inspiration for creation of the next generation of UUIDs. It has the same scheme as KSOID, but it's shorter. It fits in 128 bits. It consists of Unix timestamp and enough portion of random. We can consider it truly as a better UUID. It has nice string representation. It's shorter than UUID. It has randomness inside. It has good alphabet that can be used either in uppercase or lowercase. So it's quite a good idea, and it's popular. It has a lot of different implementations in different languages. What else can be done, and what other implementation can bring to us? Let me highlight several examples. There is a Firebase push ID. Google designed Firebase. They need to collect events from all over the devices. So they utilize the same layout as Elastic Flake, but they decided they don't have node ID or sequence or something. They just use a random. It's like ULID, but in another package. They used more dense alphabet, base 64, and that resulted in a quite unique and quite compact identifier. And if we are talking about randomness, there is another popular identifier called non-ID. What's the difference from other random identifier? It was designed like a better version of UUID version 4. The statement from its authors was it would be shorter in its string representation, and if someone of you tried to select UUID with double click, you always select only a part of UUID. So this identifier is selectable with double click. That's truly the statement from the authors. And of course, they copy some properties from UUID version 4 because in defaults, they have the same amount of bits, almost the same. But they allow us to create different alphabets, different lengths. So it's truly a configurable identifier when you need something random. They have built a site where you can configure your own identifier that consists of truly random data. You may use long alphabet, short alphabet, and take a look on the collision resistance of this identifier because it's truly random. We may use it for different things like session identifier or some prefix or request ID and so on. So what else can be done to unique identifiers? We already seen a lot, and one more thing I want to highlight is how we can play with random more. This example is from identifier of NUTS. NUTS is a messaging system, and they need a lot of different identifiers and different identifier generation speed. They don't want to introduce some coordination, so they wanted to generate random identifiers, and they want some monotonicity, but at the same time, they wanted to be entropy pool friendly. They wanted to be friendly to true random. So they solved this issue the following way. They used true entropy source, hardware random, to generate one part of identifier. That part is considered as temporary node ID. So when we restart the process, we consume 71 bit of entropy, create new node ID identifier, and then every such node generates identifier in a randomly sequenced manner. So we create a random offset and then increment it by random numbers. And when we exhaust those pool, we can generate new node identifier. So in one way, it's truly random identifier. But in another way, it behaves like node ID plus sequence. Quite interesting approach. And if you are designing your ID, you may take some parts of it. Another interesting idea is CUID version 1. They combined everything that existed. So they used a timestamp, a sequence, and a fingerprint that acts like node ID, and some random data. They were designed for use in browsers. It's quite good. It was served for more than maybe 10 years. But then they get, I don't think, mad about security, cryptography, and base 36. They created a big list of, they called this disqualifiers and qualifiers. They wanted identifiers to be secure enough, not predictable, not very fast generatable. So they created a list and followed it. So they created completely new identifier, CUID version 2. It looks like natural identifier because it starts from SHA-3, cryptographically secure hash function, and then inside that SHA-3 they put a lot of different data like timestamp, random, counter, fingerprint, and so on. If I represent the scheme like I presented everything, I of course cannot fit it on the slide, so I disassembled it. And if you take a deep look, you understand that CUID version 2 is CUID version 1 packed inside the SHA-3 and with some portion of it. It's interesting approach. There is a lot of interesting insights on the page related to CUID version 2, but I'm not sure about great usefulness of CUID version 2. So, is that all? Almost. A year ago, exactly a year ago, was introduced new RFC, RFC 9562, that about universally unique identifiers. It obsoletes previous RFC about universally unique identifiers and introduced 3 new versions of UUIDs. And the most recent talks about identifiers are often related to UID version 7. So since I'm talking about identifiers, I need to tell you about them also. It was a long way. It took them, for example, like 4 years to discuss how to do this, how to create new version of UUIDs. At first place, they decided to implement only version 6, but then they continue to do something new and new and new and make some updates. And if you read the documentation of that, if you read that RFC, you may find that there is a motivation for updating RFC for UUID. And if you take a look at those lists of different identifiers, you may find that we already take a look at almost all of them. The ones that I didn't consider today are very similar to something else already considered. So let me tell you what is different new UUIDs. UUID version 6 is the same as UUID version 1. It's time and node based, but they fixed its monotonicity. In UUID version 6, we have high, mid, and low bits of timestamp ordered in a correct order. So when we generate UUID sequentially, we receive monotonic sequence. And UUID version 1 and 6, fully compatible, they can be converted one to another, just by replacing bits and changing version. So what is UUID version 7? It's also quite interesting. It consists, at the first look, from timestamp and some random parts. If we put ULIT nearby, we may see it's like ULIT with version and variant. So is UUID version 7 ULIT? No. If you take a deep look at the documents, you may find that there are no strict requirements but recommendations for layout of UUID. There are 2 parts, rand A and rand B, and they may use either pseudorandom sequence, or they may use of something like counter or another guarantees to guarantee uniqueness or monotonicity. So for randomness, is everything okay? We are familiar with random, so nothing new. It's like in ULIT. But for monotonicity, they propose use of 3 different methods on implementing this inside UUID version 7. So when you see UUID version 7, you didn't exactly know what is inside it. For example, one of the popular implementation, UUID version 7 for JavaScript, it consists of timestamp, sequence, and random. This library was then copied to Rust. Then its implementation was copied to Python implementation of UUID version 7. Almost the same approach was chosen for Postgres implementation of UUID version 7. So when you see UUID version 7, you did not know exactly what's exact bit layout until you open the library and take a look at the exact implementation. So I may say that UUID version 7 is something like this. It starts from a timestamp. It always starts from a timestamp in a given form, but then it may continue with some bits of more precise timer, or it may continue from random or by sequence and so on. So it's up to you. You may implement your own UUID version 7 if you follow the rules. But if you want to change something else, for example, you don't like this timestamp and you want to encode it in another way, they decided to give you the freedom. UUID version 8, it's complete freedom in 122 bits. They stated that you may put anything you want in every of custom fields. Only that you want to fill is version and variant. So UUID version 8 is anything. You may put any kind of bits, and it's not not RFC's responsibility, but your responsibility, how you will achieve uniqueness, unguessability, and so on. So let me compare overall everything that I showed to you. I put all the identifiers and their bit layouts in one picture. This picture was also the point where you may take a photo of the next slide. At first place, I started from this picture when I started comparing different identifiers to take a look at their capacity in bits. But then I found that not only their bits representation matter. Bits, it's how it's stored in a database, if a database is able to store it in a most dense and compact form. But often, we may find a situation when someone took a UUID in its string representation of 36 characters and put inside the string field in a database. It's not an efficient way of storing UUIDs, but people do this. So when you transit your UUIDs through network in your XML or JSON or something like that, you transfer them in a string way. So it's always worth to see what's the string length representation of this identifier, because you will see it in JSON, in logs, and in many places when it will spend also some bits of capacity. And let me sum up with some tips and tricks that you may think of if you will try to build your own identifier. First, time tricks. You don't need to generate identifiers in the past. So you may adjust the epoch when your identifiers start. It's always maybe the most recent timestamp, and that would be OK. You may choose different density for timestamp representation. That will allow you either better monotonicity within timestamp or better capacity or less bits spent for timestamp. For Node ID, there are a lot of approaches. Still, you can use MAC address, for example, in IoT. Different devices have different addresses, and that would be OK. If you need to put very little amount of node IDs, like 1,000, use coordinated approach like it was done with Twitter. You may contact something like etcd console or Zookeeper and query for some small enough ID that will be unique to your node. And until you keep it, no one will take it. So then, with coordinated approach, you may maintain node ID very small. You may derive node ID from something you already have. If you have enough bits, for example, for randomness, you may use random. Or, for example, if you have Kubernetes pod name or something like that, you may put that into hash function and then take a part of that hash function as node ID. with quite good confidence. For sequence, you can use generic sequences, or you may use combined approach of sequence and randomization. You may start at random offset and increment with random increment. That will result in either random and monotonic fields. And there is a trick about sequence limit. When you have a small amount of bits for sequence and you expect some spikes in ID production, for example, you receive a bulk of data and you need to produce a lot of identifiers at the same time, you may borrow either from the future. The common approach for all the identifiers is to borrow from the future. If you exhaust your sequence, you will wait for the next millisecond. But if you are not spending the sequences from previous timestamp and you not expect exact monotonic sequence, you may remember that in previous time slot you not spend some of sequences and reuse them. For random, please be aware of different sources of random. The most good and most usable random is dev-urandom. It's quite good. You will not face anything problematic with it. You will not see a collision if you have enough bits. If you are working with something algorithmic, classic random function in your language is algorithmic approach. It requires seeding. If you seed it with the same values, you will result in the same sequences and the same identifiers. What's the problem with random seeding? What I want to highlight. In previous days, it was often used like PID and timestamp for seeding the random sequence. What's the problem with PID and timestamp? In the era of Docker, when the fleet of Dockers start at the same time, so there is a huge probability they will start in the same millisecond. They start with process ID number 1. So a lot of different containers on different hosts at the same time receive the same seed for random and start generating the same sequences. So there is a problem with random seeding. Always use true random or good random source for seeding algorithmic random. Or better, don't use it for unique identifiers. And one more problem with such identifiers, okay, you generated a good source for seed, you created it, and then your process did a fork. And two different processes have the same seed and the same state of random generator and generate the same sequences. And beware of birthday paradox. Who are familiar with birthday paradox here? Okay, for those who are not familiar, I have half a minute to explain. It's about how many people we should have, for example, in a room to have a 50% probability that someone have a birthday in the same day. And we need only 23 people. For the 365 different days, we need only 23 people to have a collision in a birthday day. The same is for different random sequences. So birthday paradox cause collisions way earlier than our brain expect it. So beware and always check the collision probability and how fast it would be. Think of different alphabets for representation, because, for example, decimal alphabet is okay for us as a people, but if you take those comparisons, you may find that decimal representation may be longer than, for example, flake ID with twice bigger bit representation. And, of course, think of the purpose of your ID. Don't use something complex and unpredictable and guessable if you need it for temporary session or something in logs or request ID. So think of purpose of your ID, required generation rate. Of that you can think of probabilities and collision. If you need no collisions, then don't use random. And think of for which entity these identifiers would be used. Would be used by humans or would be used they by machines? Would be they encoded or would be they in strings? Do you require monotonicity or random distribution is okay for you? Think of global uniqueness. Do you really need global uniqueness or local uniqueness is okay? Local uniqueness is within your system. Global uniqueness is within a universe. So no one will have the identifiers that you generated here. And when you think of uniqueness, always think of consequences for collision. No matter which identifier you create, there is a chance that by wrong implementation, that something was copied, something else happened, and you receive the same identifier. What would be in this case? So think of consequences of collision, and maybe you would be okay with shorter identifiers, because you can resist to those collisions. And think of information disclosure and some predictability and unguessability. There is a security advice from my side. Please do not use identifiers as secret tokens. It's not a secret token. It's identifier. For secret tokens, use something random that was designed for this. And to summarize, if you are building your identifier, think of case-sorted approach. It's used in almost every identifier based on time. Use dense alphabet, put enough random to avoid guessing, and if you don't want to use random, use sequence. It's better in bit utilization. And if you want to play with something, you may visit the site I've created. It looks like this. It allows you to play with different layouts for identifiers. When I created this presentation, when I designed it, when I researched for different implementation, I wanted to check something like how this identifier would look with different alphabet. What if I change this bit or increase the timestamp or adjust the epoch, or what would be collision resistance and so on. So I created and combined this in a single site. So any of you may visit it and try to build your own identifier and test how it would be good or bad for you. Thank you, everyone, for listening this long and hard talk with a lot of different information and numbers. Thank you, everyone. I'm ready to answer some questions if I have time.
Big applause. So one of the results of this session, finally, I revealed a little bit about personality of Elon Musk, actually. So he has 11 children, right? And he really worries about collisions. That is why his 7th child, the name was X-A12, right? Something like this. So that's the reason. So anyway, so every time when I hear your sessions, it's like I read in 1 hour time frame, I read the whole Britannica encyclopedia, right? So my brain is smoking, but I know where I can check. So that's why, guys, probably we have time just for one question, and next catch the Mons and ask for his presentation as a reference for these smart things. So one question. So these gentlemen, please.
Thank you for your talk. What is your opinion about UID version 8? It's like final destination because they just did not provide. They just provide you a contract, right, for backward compatibility or like forward future compatibility. But like, what is the point of it?
Okay, from my point of view, from the research I've made, I think UUID version 7 would be the successor for UUID version 4. Postgres implemented version 7, not 6. Different libraries implement version 7, not 6. And I think in some time, version 7 will move away version 4. But from my side, I don't like UUIDs at all. They are long enough with their string representation, and I cannot select them with double-clicking.
But about version 8?
Version 8 was a transitional version. I don't think it would exist only in legacy systems that need to migrate from version 1.
Thank you.
Okay, thank you. Thank you very much. Big applause. And do not forget to say thank you and share your feedback.